Its trajectory, its elongated shape, and its inexplicable behaviors made it one of the greatest enigmas of modern astronomy. From the moment it was first detected in 2017, the object named Oumuamua, Hawaiian for scout or messenger, defied everything scientists thought they knew about celestial visitors. It wasn't merely unusual, it was singular. Unlike any asteroid or comet observed before, Oumuamua's presence signaled a profound mystery, and in doing so, ignited a global scientific firestorm. Now, thanks to the James Webb Space Telescope, humanity has its first real image of this enigmatic interstellar traveler, a momentous development in our pursuit to understand objects from beyond our solar system. Oumuamua looked like nothing we had ever seen before. Unlike comets, it had no visible tail, no signs of outgassing, no evaporation of volatile materials that could explain any comet-like acceleration. And unlike asteroids, its motion through space could not be explained purely by gravitational interactions. In fact, its acceleration away from the Sun appeared to defy Newtonian expectations. Scientists were left without sufficient answers. It was moving in ways that known forces couldn't easily account for, and its peculiar characteristics prompted a cascade of theories, ranging from natural phenomena to the radical idea that it might be artificial. Since its discovery, hypotheses have been put forward attempting to explain what Oumuamua could be. Some speculated it was a fragment of solid hydrogen ice, potentially capable of sublimating without leaving the usual cometary signs. Others entertained more exotic possibilities, that it might be an artificial spacecraft, a probe from an advanced civilization designed to explore star systems such as ours. These ideas, while controversial, reflected the desperation of a scientific community struggling to explain what had entered our solar system without warning, and left just as mysteriously. But no answer had been conclusive, until now. Launched in December 2021, the James Webb Space Telescope was designed to solve the deepest mysteries of the universe. As the most powerful space observatory ever created, its advanced instrumentation allows it to observe the cosmos in the infrared spectrum, capturing details impossible for other telescopes operating in visible or ultraviolet light. This gives it the unique capacity to study faint, distant, or cool objects that other telescopes cannot detect. When Webb turned its gaze toward Oumuamua, now much further from our solar system, it captured something incredible, the first real image of this mysterious interstellar object, offering an unprecedented glimpse into its nature. The image that Webb returned has confirmed what could only be speculated before. Oumuamua has an elongated and asymmetrical shape, unlike the mostly spherical or irregular chunks of rock and ice that populate our asteroid and Kuiper belts. Its body is marked by grooves, ridges, and craters, scars carved by billions of years traveling through interstellar space. These surface features are not random. They are testimony to collisions with micrometeoroids and exposure to radiation in the most extreme environments imaginable. But what truly astounded scientists was not just its shape or texture, it was its composition. What is most surprising is the composition of its surface, complex organic compounds and elements not commonly found in our solar system. The James Webb Telescope's instruments revealed that Oumuamua's skin is coated in a mix of carbon-rich materials and exotic minerals that resist classification. This, of course, suggests that Oumuamua originated in a cosmic environment very different from our own, possibly around a star system with a unique chemical makeup or evolutionary history. Such findings have expanded the boundaries of what we consider possible in planetary formation and composition. One of the biggest enigmas of Oumuamua has always been its anomalous acceleration as it leaves our solar system. Webb's observations have ruled out outgassing. There's no evidence of jets of gas acting like microscopic thrusters to push it forward. However, this conclusion only deepened the mystery, while raising new and even more fascinating possibilities. One intriguing theory now being considered is that the acceleration could be caused by an exotic mechanism such as a light sail, a hypothetical propulsion technology that uses the pressure of photons from starlight to travel vast distances. This concept has long been proposed by scientists exploring advanced forms of space travel. If Oumuamua were using such a method, it could mean that it is not a natural object at all, but a technological artifact, either derelict or still functional. Thanks to the James Webb Telescope's ability to analyze the light reflected by Oumuamua, scientists have managed to unravel the detailed composition of its surface with an unprecedented degree of clarity. The data reveal a mix of metallic and mineral compounds unknown in our solar system, along with traces of elements that could form organic molecules. This opens a gateway into studying a chemistry forged in alien conditions. Among the most fascinating findings is the presence of a highly reflective material, something that could explain Oumuamua's unusual brightness, which puzzled astronomers during its initial flyby. Additionally, Compounds have been identified that suggest Oumuamua may have formed in a young, dynamic star system, one where chemical reactions occurred under conditions significantly different than those found in our own stellar neighborhood. These discoveries offer key clues about the processes occurring in regions of the universe where matter is organized in completely different ways than in our own corner of space. This diversity of formation environments, long theorized but never directly observed, implies that there could be countless exotic objects wandering the interstellar void. One of the most recent and compelling theories suggests that Oumuamua could be a fragment of a planet destroyed by extreme gravitational forces. These forces, possibly caused by a massive star or a nearby black hole, could have stretched and torn the planet apart, forming object fragments with unusual shapes and properties. If this theory is correct, Oumuamua would be a survivor of a catastrophic cosmic event, carrying with it the physical history of a lost world. Its very existence would be proof of how violent and dynamic our universe truly is. This hypothesis opens up a new window into the life cycles of planetary systems. It allows astronomers to study how star systems evolve and change over time, and how cataclysmic events can give rise to objects that end up traveling across vast galactic distances. The organic compounds found on Oumuamua's surface have led to renewed speculations about its potential role as a carrier of the building blocks of life. In a universe full of possibilities, could Oumuamua be a natural vehicle for distributing these life-forming molecules to other star systems? This phenomenon, known as interstellar panspermia, raises the tantalizing possibility that objects like Oumuamua may play a key role in spreading the ingredients necessary for life across the cosmos. If true, this would not only redefine our understanding of how life might originate in multiple parts of the galaxy, but also make us reconsider the origins of life on Earth. Could our planet have been seeded by material from a similar interstellar traveler? Could our ancestors, biologically speaking, have arrived in microscopic form, clinging to the surface of something very much like Oumuamua? Oumuamua is more than an interstellar object. It is a time capsule that carries with it stories of cosmic events that occurred billions of years ago. Its study not only teaches us about its origin, but also about how star systems interact and evolve throughout the galaxy. In addition, the analysis of Oumuamua lays the groundwork for future missions designed to intercept and study these interstellar travelers directly. Such missions could offer a new perspective on galactic dynamics and the diversity of planetary formation. This discovery is a profound reminder that the universe is still full of mysteries waiting to be uncovered. And Oumuamua is just the beginning. It has not only challenged our scientific theories but also our perception of our place in the universe. Its arrival reminds us that we are a small part of a vast and immense cosmos, where strange events unfold continuously, even far beyond our sight. If this object has an artificial origin, it could represent the first indirect contact with extraterrestrial intelligence, a possibility that would transform our understanding of life and intelligence in the universe forever. Oumuamua has inspired, of course, a new generation of scientists and engineers to think beyond the limits of our solar system. Projects like Breakthrough Starshot, which seeks to develop lightweight, laser-driven probes capable of achieving relativistic speeds, are just the beginning of a new era of interstellar exploration. These future missions could not only intercept objects like Oumuamua but also explore their characteristics in detail, helping us answer the most profound questions of our time. With each discovery, we move closer to a future where humanity may not only observe the universe, but interact with it in ways that we can now only imagine. Oumuamua, the interstellar messenger, is much more than an object that happened to cross our solar system. It is an open door to a universe full of possibilities and unresolved mysteries. Its discoveries have transformed astronomy, inspiring fundamental questions about our origins, our place in the cosmos, and our collective future. Thanks to the James Webb Telescope, we have taken another monumental step forward in understanding what it means to be part of such a vast and complex universe. Oumuamua is a reminder that although we are small, our curiosity and desire to explore make us great. The universe invites us to dream, and Oumuamua is just the beginning of that dream. What other secrets await us out there, still cloaked in the darkness, waiting to be found? As astronomers continue to scrutinize the data provided by the James Webb Space Telescope, the mystery of Oumuamua continues to unfold like a cosmic puzzle, piece by piece. Every spectral analysis, every photon captured from its reflective surface, brings with it new layers of curiosity. One particularly riveting line of inquiry now focuses on the nature of the reflective material found coating parts of its outer shell. Early theory suggested that this sheen might be caused by a thin layer of metallic hydrogen or frozen exotic gases, but Webb's data proposes something far stranger, a substance with optical properties inconsistent with any known material found within the confines of our solar system. Could this be a form of artificial coating? Or might it be a natural byproduct of exposure to intense cosmic radiation over eons, sculpting Oumuamua's surface into a mirror of alien chemistry? This enigma has led researchers to revisit the idea of panspermia, not just as a theoretical possibility, but as a tangible process that may actively occur via interstellar wanderers like Oumuamua. The discovery of organic compounds, particularly the kind that could serve as precursors to amino acids, reignites the hypothesis that life, or at least its foundational elements, can be transported across star systems. If Oumuamua did originate from a young, volatile star system, it could have passed through zones dense with organic-rich material, collecting them like cosmic pollen. Over millions of years, such compounds may remain stable, protected beneath crustal layers, only to be delivered to fertile environments like early Earth. This makes Oumuamua not merely a visitor, but a potential messenger of life's universality, a possibility that compels both wonder and scientific pursuit. Intriguingly, computer modeling now attempts to trace back Oumuamua's potential point of origin by plotting its past trajectory. Though this proves difficult due to the object's non-gravitational acceleration, models suggest that it may have been ejected from a binary star system. Binary systems, where two stars orbit one another, can be highly unstable environments. Objects caught between their gravitational tug-of-war may be violently flung into deep space. If Oumuamua is a product of such an ejection, it would explain both its speed and its unusual tumbling motion, as well as its elongated and chaotic shape. Furthermore, the possibility that Oumuamua could have been an artificial probe, either long dead or still operational, has not been completely discarded by all scientists. The notion was first introduced by Avi Loeb, a prominent Harvard astrophysicist, who argued that the object's acceleration and trajectory defied natural explanations. Though the majority of the scientific community regards this hypothesis as speculative, it has nonetheless injected a vital spark into public interest and academic discourse. After all, the mere suggestion that we might have intercepted relics or beacons from another civilization compels humanity to think far beyond its terrestrial limitations. Even if Oumuamua is natural, its behavior provides a roadmap for detecting future interstellar objects with similar trajectories. The Webb telescope has now been calibrated to flag anomalies in deep sky movements, essentially functioning as an early warning system for visitors from beyond. This has inspired mission proposals to send rapid-response spacecraft capable of rendezvousing with such objects. These missions, some already in the conceptual phase, envision compact probes equipped with high-resolution imaging and spectrometry tools, capable of matching speeds with these fast-moving bodies and relaying real-time data back to Earth. In doing so, we could study these objects up close, perhaps even deploy landers or sample return capsules in the future. As we look ahead, it becomes clear that Oumuamua's legacy will endure not simply in scientific journals, but in the collective imagination of a species forever reaching upward. It is already inspiring the next wave of thinkers, engineers, and dreamers. Universities have begun launching interstellar studies programs, blending astrophysics with speculative design and astroengineering. Museums around the world are dedicating exhibits to this strange traveler, showcasing simulated models, artist interpretations, and the raw, pixel-rich images.